Okay, so I was asked to talk a little more about expanding and condensing logarithms. So let's go over some of the base ideas around it, some of the tools that you're going to need to be able to do this. Okay. Um, One of the first tools that is going to make a pretty big difference in a lot of these is going to be one of the old exponent rules, which is that roots, say the nth root of something raised to the p power, let's call it, can be expressed as a fractional power. Okay, so this one would be expressed as x to the p over n. If you just had the nth root of x, that's x to the 1 over n power. Those two rules are going to be incredibly helpful for doing condensing and expanding. Another exponent rule that is going to be really helpful is that if you take a power, x to the n, and raise it to another power p, then you multiply the powers. Okay, that's going to be another one that's important to us. So those are the exponent tools. There is also the logarithm rules, and we're going to need those tools. And this says one of the first ones is that the log base b of something, of some x, plus log base b of something else, some y, condenses into log base b of those two things multiplied together. Okay, x times y. And of course, you can expand them in the other direction, right? If you have one log base, a log base b of x times y, it can expand into log base b of x plus log base b of y. So that's going to be a big important tool. We see the same relationship in subtraction. If I'm subtracting two things, two logarithms with the same base, log base b of x minus log base b of y, then they condense into log base b of x over y. They condense into division. So those are two of the big ones. And of course, if it's already condensed, you can expand it. Another one is the power rule of expanding and condensing, which says that if you've got something multiplied, so a times log base b of x, it's the same as log base b of x raised to that power. So these are the basic tools that we're going to need. And the trick is that you're going to have to use them in combination. You're going to have to know when to use them, and you're going to have to know when not to use them. Okay, so let me take you through an example. This example is on the is a problem on the 3-3 study guide, and here's here's the problem. We're going to do log base 3 of this division problem. 5 times r to the 5th over the cube root of t to the 2nd. Okay, and we want to expand this. So this one's been completely condensed. So when I look at this, let me tell you what I see. I see it's got a top and a bottom. Okay? And so the first instinct would be, let's expand the top and bottom, separate them out into subtraction. So that'll be log base 3 of the whole top minus log base 3 of the entire bottom. Okay. And then I got to start working on expanding each of those things individually. I'm going to deal with that minus in a second, but let me start with this right here, with this first piece, and I want to expand that as much as I can. So think of it as I've got that piece and that piece being multiplied together. And because of that, I can expand that into addition. So it'll be log base 3 of 5 plus log base 3 of r to the 5th. Okay, so that's this much. Okay, that's all that together. And it's still minus log base 3 of the cube root of t squared. And I'll deal with that after I've completely expanded this. So now this part right here, that part can't be expanded anymore. There's nothing else I can do. 5 is a prime number, so that's not anything multiplied by anything else. So I can just leave that part. This part, on the other hand, if you look at it having this exponent here, I can use the exponent rule. I can take that 5 and move it to the front, turn it into multiplication, expand it into multiplication. So I'd get log base 3 of 5 plus 5 times log base 3 of r, and then minus this log base 3 of the cube root of t squared. So I've got that first part. So now this up here is now all of this, and there's nothing left for me to expand on that. So I'm finally done with that expansion, and I can leave that alone. So the next thing I'm going to do is I'm going to change the minus here, that minus, into plus negative. And the reason I'm going to do that is because I'm going to have to expand this stuff here, and I'm not sure exactly where it's going to go. If I expand it into some sort of addition or subtraction, then I can see that this negative will wind up distributing, and if it doesn't, I can change it back into a minus pretty quickly and easily. So the trick to that second part, let me copy this first part here. And then the trick to this second part is writing this and this, using the fact that I know that roots and powers together can be written as fractional exponents. I'm going to write that whole thing as a fractional exponent. So this would be negative log base 3 of t to the 2/3 power. Okay? And that then can move to the front. And I think you'll see that we're done there. And then we have log base 3 of 5 plus 5 times log base 3 of r plus negative 2/3 times log base 3 of t. And if you want to, you can take this plus negative and you can turn it back into a minus. But that's a perfectly acceptable answer, and that is as much as you can expand this, because there's no like terms to put together, anything like that. So that is that first example. I'm just going to continue on to the next example. We're going to expand one more. Log base 10, the common log, so you don't typically write that. Log of a minus 2 times b plus 4 raised to the 6th power. That's a 2. All of that over, hang on, let me fix that 6 a little bit. Still didn't fix it. There we go, that's a little bit better. Over 9 times b minus 2 raised to the 5th power. Okay, so we want to expand this again. This is all in one logarithm, and we're looking to expand it into multiple ones. So again, what I see is I've got division here, okay? And I can expand that division into subtraction. So let me do that first. This is log, remember that's log base 10, of all of this stuff, a minus 2 times b plus 4 raised to the 6th power minus the common log of 9 times b minus 2 raised to the 5th power. And let me again work on expanding that completely before I deal with this minus and the expansion on that and what exactly that means. So notice that in here I've got multiplication right there. You don't see it, but of course when you have two things next to each other with parentheses, you're meaning multiplication in these sorts of cases. So I can expand that into addition. So that'll be the common log of the quantity a minus 2 plus the common log of the quantity b plus 4 raised to the 6th power. So there's that part, minus, and I'm just going to copy this for now, 9 times b minus 2 all raised to the 5th power. And I'll expand this all the way before I deal with any of this because of that minus sign, and that might cause me problems. So I'm going to work on what I can expand without worrying about that minus sign, and then I'll worry about the things with that minus sign afterwards. Now, very important here, look at that, the a minus 2 there. That, it turns out, you cannot expand. This is not log times a minus 2 where you could do a distribution. So you just have to leave that as the log of a minus 2. So when you have ones that look like that, that is something you cannot expand. Okay, you can only expand multiplication and exponents and division. You cannot expand addition or subtraction. You expand to become addition or subtraction, but you cannot expand addition or subtraction that's already there. Okay, so log of the quantity a minus 2 plus, and then I can move that 6 out to the front. Okay, so it'll be 6 times the log of b plus 4, and then minus log of all this junk over here. So then I'm going to look at this and notice now that you cannot expand that stuff, the stuff that I've just put in brackets. You cannot expand that anymore. So I'm done with that side. So now I need to move on to the other side, and I'm going to start by changing that minus to plus negative. Let me do it a little bit clearer. Change that minus to plus negative. And then I'm going to look at it and go, okay, right there, I've got multiplication. So I can expand that multiplication into addition. So log of a minus 2 plus 6 times the log of b plus 4 plus the negative of, and this is going to be important here, I'm going to put a set of parentheses because that negative, as I expand things, is going to have to distribute to all of it. So this multiplication that exists right there, that is, it says 9 times b minus 2 raised to the 5th, is going to expand into addition. So log base 10 of 9 plus log base 10 of b minus 2 raised to the 5th power. Okay, so now let me move that 5 to the front, and then I will be able to distribute the negative at the end, and then I'll be done. Okay, so 6 times log of b plus 4 plus the negative of common log of 9 plus 5 times the common log of the quantity b minus 2. Okay, so now this negative is going to distribute, and then I'll be done. So that'll be the common log of a minus 2 plus 6 times the common log of the quantity b plus 4 plus negative common log of 9 plus negative 5 common log of the quantity b minus 2. And that is the full expansion. You could, of course, turn those plus negatives into minuses if you wanted to, but I think you guys know how to do that. So that is expanding them. Next, I'm going to do a couple problems on condensing. So if I gave you a problem like this, let's say 11 times log base 9, wow, I'm having a hard time writing the 9. 11 times log base 9 of the quantity x minus 3 minus 5 times log base 9 of the quantity 2 times x. let's say I want to condense that as much as I can. So one thing you might see is this minus here, and the fact that I've got the same base for both logs means that I could turn this minus, I can condense it into division. Now this minus I cannot, because that's part of that logarithm, and again, you can't do anything with that. But the problem is, before I deal with that minus, I have to deal with these numbers out front. Okay? So I'm going to take this 11, I'm going to make it a power. I'm going to take this 5, I'm going to make it a power. Okay? So that's going to give me log base 9 of x minus 3 all raised to the 11th power minus log base 9 of 2x, that whole thing, raised to the 5th power. Okay? And there's maybe something you can do with this 5. You could do it to both of those. So maybe I'll do that. I don't know that it's 100% necessary, but it's easy enough to do in this one. So usually when it's easy enough to do, you tend to do things like that. So it becomes log base 9 of, and this stems from the exponent rule, that if you have two things multiplied together and raised to a power, it is the same. This is some side notes here. It is the same as doing each thing individually to that power. Okay, so that'll be times 2 to the 5th and times x to the 5th. And one of the reasons you might do that is because 2 to the 5th is not all that difficult to figure out. 2 to the 4th is 16. You can think of it as 2 squared squared. So 2 to the 4th is 16, and so 2 to the 5th must be 16 times 2, which is 32. So I can write this one more time as log base 9 of the quantity x minus 3 raised to the 11th power minus log base 9 of the quantity 32x to the 5th. So I'm just trying to do the things that I can see immediately. And now I've got this minus here. And if I want to keep condensing, that minus has to condense into division. Okay, so that'll give me log base 9 of a fraction now. And at the top of the fraction is going to be this x minus 3 raised to the 11th power. And at the bottom of the fraction is going to be this 32x to the 5th. Now at this point, if it was possible, I would be looking to cancel some things within the fraction, but that's not actually possible in this one. So this here becomes my final answer. Okay, so that's condensing 1. Let's do one more. And let's condense this one. We'll do 3 over 4 times the natural log. Remember, that's the log base e of the quantity 2h minus k plus 3/5, 3 over 5, times the natural log of the quantity 2h plus k. And we'll see what we can do with that. Now, both of these things, these multiplications, can move to become exponents. So that's what I'm going to do first. So that'll be the natural log of the quantity 2h minus k raised to the 3/4 power plus the natural log of 2h plus k raised to the 3/5 power. Okay? Now, remember, this and this have to stay that way. There's nothing I can do with that. But this addition right here can condense into multiplication. So what I can do is I can say this is like the natural log of, and we're going to need some brackets here because we got a lot to write, 2h minus k all raised to the 3/4 power times 2h plus k all raised to the 3/5 power. And that's getting pretty close. The only other thing you could do is you could look at these exponents and you could say, oh, well, I can turn each one of those into roots and powers, and you might want to do that, you might not. It depends on where you're trying to go with the problem, to be really honest. But like that first one would be the 4th root of the quantity 2h minus k raised to the 3rd power. Let me write that for a little bit smaller. The 4th root times the 5th root of 2h plus k raised to the 3rd power. Now, that seems like as much as we could do, because I don't see any good way of putting those together since they are different roots. Okay? It might seem tempting that maybe you could put them together because of these 3's here, but those 3's don't really mean anything without the roots being the same. So that's as much as they can be put together. Okay? So that is everything about condensing and expanding that I'm going to do in this video. If you have further questions, let me know. The trick, again, is to use all the properties, all the little tools that I talked about here on this first page, and I'll let you get a look at them again, and use them in the right combinations. And sometimes that takes practice to do, but you just got to keep working at it and trying it, and it's something that you'll be able to do. Okay? Thank you for listening. This is the end of the video.